Hi guys, and again an electrophoresis power supply. This is for now the last one in the series of my electrophoresis power supplies I have to show you. This is a baby, it's a small one. It's a CONSORT E321, 321. It is rated, it can output 250 volts up to 100 milliamps. So it's not a big thing. And the most interesting thing is, you will see, it has a transformer inside, a linear transformer inside. For this, I will use my first version. This is absolutely put together fast because I needed a solution, high voltage power supply, high voltage dummy load. Yeah, this is how it looks. It can be used for up to 1 kilovolt to 100 milliamps, and it can use up to 200, maximum 200 watts when the fan is in full power. But this is a topic of another video I will make exclusively only for that, because it's fairly easy to use. And as I said, the first step. What I'm planning is much more complicated, will go much higher on voltage and power, and will be completely digital. Yeah. But anyway, we're here for the power supply. So let's turn it on. It says E21. At least it knows his name. Yeah. Anyway, so we're at the off state. This is extremely minimalistic. If you go to set, you have set voltage, up, down. Then you go to current. Here you see the line for the milliampere, up, down. Then you could set the hours, that I'm not interested in at all. To be honest, I don't know what that is. I'm not interested either. And then you can say run, and you can say set. Yeah. It ramps up, but it will soon stop because it will not see any load. Oops, it's going already down. See, it's missing a load. So let's turn on. Banged my head on the lamp. Let's turn on the load. It's still 100 at 0. We have to restart. As you can see here, the lower display is the voltage, the upper display is the current. Now the electronic load is loading. It is 246 volts and it draws 100 milliamps. The thing is, you're not seeing, it doesn't measure how much you draw or anything. It's just set what has been set, and if it is over voltage is not possible, over current, it will start to ramp down. That's all. That means if I'm now at the 100 milliampere range, if I go to the 500 milliampere range, it will go down to, let's see how far down it will go. Don't do nothing. I don't understand what alarm. Yeah, it should be alarm. Anyway, yeah. Let's go a little bit more down. Let's get at 0. Like that. Okay. And use the set again to rearm it or not. Okay. Have to turn it off and on probably. As I said, it's quite minimalistic. I have put a load of 27 milliamps. It's ramping up to 250 volts. That's it. Reached the maximum. And now I'm slowly increasing the current. We are at 60 milliamps, everything is okay. If the line, the LED, the milliampere line starts to blink, it says we reached maximum. Let's go all the way up. 100, yeah, 104, it's already ramping down. Went back to 70 milliamps. Go to the 100 milliamp range again. Go all the way up. '85, '96, '99, almost 100 milliamps. So now this is the maximum that this thing can deliver. 250 volts at 100 milliamps. Let's see if it's a little, it's only 25 watts. It's not even hot. By the way, this is an IGBT, what you see here. 1.7 kilovolt IGBT, capable of a lot. So that's, it's already blinking the milliamps, that it's reached absolute maximum. Yeah. Good. Let's see now how it looks inside. By the way, if you like what you see, please hit the like button and subscribe my channel. This will help me. Thank you. Anyway, let's see what is inside now. So this is how it looks inside. Three PCBs, display, CPU logic, and analog. And here is the big transformer I mentioned. Look at that. It is just an isolation transformer with 65 watts, 220 volt primary, 220 volts secondary. But it's a really nice transformer, chunky. It's the biggest thing in this box. We have a filter, a mains filter, switch. The logic itself is probably a microcontroller that I cannot see because everything is stacked here together. It's not very interesting. You have an EEPROM, not even with a cover on the glass, on the erasure, on the erase glass, the erase hole, with the firmware. The interesting here this is not a DC-DC, it's a linear power supply with phase control, with a TRIAC phase control. And this seems to be the TRIAC. Let's see. No, this is not the TRIAC. This is the auxiliary power supply. The TRIAC seems to be just a smaller one, this one. Anyway, you can imagine what you get. This is the TRIAC. Cannot really see it, but this is probably the TRIAC. You can imagine how the waveform looks, what you get. Nice build. Of course, again, completely hackable. This part can be changed to give a better DC output and not a pulsing output. Very nice transformer. But I cannot even say it is a high voltage. For me, high voltage is over 3 kilovolts. Yeah? This is up to 3 kilovolts to 4 kilovolts is lower voltage. High voltage starts to 10 to 15 kilovolts or something. This is, I don't know, low voltage. Yeah? 250 volt at 100 milliamps. This is what this thing can deliver. no more, no less. And about this power supply, why I say always power supply? Anyway, this dummy load, this high voltage dummy load, there will be a dedicated video because it's easy to build. And it's an interim build till I finish my other design that's much more sophisticated than that, of course. Yeah. This is something in between the crude lamp in series, in the incandescent lamp in series dummy load, and the one that is planned in the future. So, and again, this thing in action. Again, enclosure closed. Not very dramatic what is inside. This thing is really small. Look at it in comparison to my hand, yeah, to my palm. It's a really small enclosure. 250 volt max output, not the best DC level. At 100 milliamps max, completely analog. That means you deal maximum with 100 hertz distortion in the output. So that's for this power supply. Please consider liking this video and subscribe, please. It will help me a lot to grow the channel and to continue showing you, I hope, interesting things. Cheers guys, bye.